We will now start solving our problem we'll solve it in Microsoft Excel, and afterwards, of course, SAP Predictive Analysis and R together are going to be doing recommender systems for us and collaborative filtering. So our initial data looks like this. We have in the first column usernames. Lisa Rose is the first reviewer, Gene Seymour the second one. In the second column, product names. So Lisa Rose has looked at, for instance, Lady in the Water, Snakes on the Plane, and given such ratings in the third column. Now, what we want to do first is we often have it transformed. So users are going to be numbered. So Lisa Rose is 1, Gene Seymour 2. Then in the second column, the movies are going to be numbered. Lady in the Water 1, Snakes on a Plane 2, and then the third column will still retain ratings. Now, what we want to do in Microsoft Excel, and this workbook is of course included with the course, is we want to construct such a table. We have 7 users, or critics and Toby, 6 products, 6 movies, and we want to see, for instance, user 1, Lisa Rose, gave Lady in the Water 2.5. We want to put that there. So remember, Lisa Rose gave Lady in the Water 2.5. Now, the next thing, Lisa Rose gave Snakes on the Plane 3.5. So this is the user 1, product 2, 3.5. So we could, for such a small table, we could fill it out just by hand. It is a fact that we will need such a table if the data is initially given us in a column format that we had in the previous sheet. And we have to achieve it somehow, so that finally we would have such a table. Every user who has rated every product is written down. Now, there is, of course, a very intricate Excel formula for this. So here it is, and you would have to have taken Excel modeling class for that. So this is beyond the scope of our class. I'm going to show you the web page. So this is my course. It's totally free. It's called www.excel43.com, and you can always learn all the videos there on YouTube. So you can always learn Excel from there if you have time. Now, another thing is, once we have this table, we're going to need even 2 or 3 more tables to get all the recommender system analysis done. So what we'll be doing next is we'll be calculating such a table where both the rows and the columns are users. So for instance, 1, 2, first row, second column, this table is a similarity between Lisa Rose and Gene Seymour. So that's what we were aiming for all along. So let me write this formula down. It's going to go like this: equals correl, so it's correlation, and we've given some cunning names here. So I'm just going to have to write equals correl U1 underscore, comma U2 underscore, and it's going to tell me the correlation between the grades that Lisa Rose and Gene Seymour have given. The reason it did it that easily is because if we go back to this table here, this block here is called U1 underscore, and this block is called U2 underscore. So if I take a correlation between it, just simply shows the correlation between the 2 graders. Okay, so that works just fine. And the tricky part, however, is going to be filling all this table, all the possible correlations between all the possible authors. So that's what we're aiming. That's what we meant by in the beginning by all that by saying that it would have to be done. So now the next thing is that we can do it with an Excel formula. This is again going to be quite an intricate one. We're not going to go into it, but we could have written it like manually what is it, 7 times 7, 49 times, just manually, and it would have been fine as well. The thing is that we want correlation with itself be a 0, because usually a correlation with yourself is a 1, but we just zeroed out those self correlations because otherwise it's going to be very high always, and we just don't want to consider that correlation with yourself. We'll see that later. Okay, now we have another table to fill, and these are the Pythagorean theorems. So the formula, and remember we didn't take a square root. We did not take a square root in Pythagorean theorem. So the formula is going to be like this. Equals, remember, 1 divided by, parenthesis, 1 plus, and now the formula for doing Pythagorean theorem is sum x my2. So this does Pythagorean theorem, and I'm going to feed into it again u1 underscore and u2 underscore, and once I go to this formula, it's going to be just fine. It's going to tell me the Euclidean distance between Lisa Rose and Gene Seymour, and then do 1 divided by 1 plus Euclidean distance. So once again, this table wouldn't be very hard to fill out by just entering all those 49 formulas manually, but there is a very difficult Excel formula that can do it for you. Once again, if you take that Excel course, you'll be able to do that by the end of the course. And now the next thing that we will be doing is actually the final table. So actually, before we go to the final table, there's something I'd like to point out. So these are for Toby. Remember, Toby was user 7. For Toby, these are all the Euclidean similarities. So the user that by Euclidean distance is the most similar to Toby is the biggest number from here, 0.039. So it's the biggest similarity. And it's user 5, Mick Lazal. Now, the question is, we could already proceed from here. We could do such a thing that we'd select the movies that Mick Lazal has seen and kind of start suggesting along those lines. I would never throw off that option, because think of it, let's say that we're not doing a kind of a movie recommendation thing, that our product is in movies, but it's web pages. So think of it this way, that if you find a really smart person to attune to, suggesting the things that he has looked at might be a really good idea. Maybe it's not the average of the pack thing that he has seen, but he might have found some very interesting things. Now we'll go with the average of the pack option with the last table. Let's see how that goes. And this is our final table. So we have once again users times products, and every entry in this table is going to show us how highly we recommend such a movie to such a person. So for instance, user 7, product 6 is how highly we recommend The Night Listener to Toby. So we can see that if you remember from the first slide, The Night Listeners was the highest recommendation for Toby, given from the set of movies that he hadn't watched. So what we'll do here is we do the following formula. So first of all, we go to the initial table and take the 6th column for Night Listener. This is all the ratings that Night Listener has gotten. Let me read from here. It has gotten from Lisa Rose free, from Gene Seymour free, then a 4, 4.5, free, free. So these are the ratings it has gotten. Now we want to take all of these into account. And now we go to the Euclidean similarities table and take all the similarities to reviewers from here. This is the 7th column. In the user product, it was the 6th column because it was the Night Listener we were rating. And in Euclidean similarities, it's the 7th column because it's the Toby similarities that we're doing. And now we start multiplying them one by one. So we'll take the 0.034 and we'll multiply by 3. Then we'll take the next Euclidean similarity, 0.33, and we'll multiply it by 3. This way, we'll take each rating into account as much as similar it is to the focal user Toby. So essentially, the biggest similarity there could be in this column. These are rather small, these similarities, but the biggest similarity that there could be would be almost ones. So think of it, if there were always ones in here, then we would just basically take all these grades and multiply them by ones and take them into account to almost a full extent. Now the problem is that if it's almost ones, then we would get like a column, you see 3, 4, 4.5, 3, 3, and it would be a big number. It would be, let's count, somewhere around 20 would be this number. But we want to get it to comparable levels, so we want to get it somewhere 3.5 or whatever this weighted average would be if all the reviewers would be similar to 1 or so. So what we do is we multiply them one by one as we spoke of, and then in the end we just divide by this sum here, the sum of all similarities. So if all the similarities would be near 1 and we have done the multiplication, it would be somewhere near an 18 or 20, and then we divide by 6 ones and we get something like 3.5-ish something. Let's see how it goes out now. So we do such a thing. We go back to our recommendations and we do equals sum product is the formula. Sum product. And now let me change the sheets. I'll take this block here and comma, and the Euclidean similarities, this block here, and then enter. And here it is. Here it is. This is the 0.72 that I got. Now I have to divide it by sum of all the similarities as we spoke of. Column use. And here it is, 3.38. And here we are on our first PowerPoint, and we can see that that the night listener really was predicted to have we already at first said that it will have a score of 3.38. So the next thing we want to do is we really want to give the grades to all movies to be watched by Toby, and actually you want to project for every user all the grades for the movies they haven't seen. So now it's a question of filling this table up with all the values. It's again a very complicated Excel formula, so here it is. It uses this indirect and next to sum product, and this indirect again comes in a complicated way and so forth. So it's again for an advanced Excel course. But anyways, we could have written this formula down again 49 times and be done with it. Now, let's look at the final results. Toby has seen these 3 movies. I just wrote it down from the initial data. So his ratings, his suggestions are these: 3.38, 1.51, 2.4. So naturally, we're going to suggest that he'd watch next. I mean, the highest priority suggestion is going to be the night listener. And here we are. We're done with our ratings for Toby.